Okay, so we're working on section 3.2, which is factoring quadratic expressions. So for the first 9 problems, we have to go ahead and factor and then solve for the intercepts. So when we're factoring, we always want, well, when we're in standard form, so when we have f of x equals x squared plus bx plus c, so there's the coefficient on the x squared is 1 when we're in standard form. We want to find something that adds to b and multiplies to c. And then there's some variations on this that we're going to see in all these problems that we're going to go through. But that's kind of the general idea. We're always looking for something that adds to the middle term and multiplies to the last term when the coefficient of x squared is 1. We'll talk about what happens when it's not when we get there. So for A, part A, we have f of x equals x squared plus 3x plus 2. So we want something that adds to 3 and multiplies to 2. So what adds to 3 and multiplies to 2? 2 and 1. Now, when we go to write this, so f of x equals, we're going to set up 2 binomials. Each are going to start with just x. And we can notice that we have plus 3 and plus 2 happening here. So we're just going to add 2 to one of the x's and add 1 to the other x. We don't have to worry about the signs. Any questions on that? Okay. Then to go ahead and find the x-intercepts, we're going to set each of these equal to 0. We'll set this whole thing equal to 0. So we have x plus 2 equals 0 and x plus 1 equals 0. So our x-intercepts, this means that our x-intercepts are minus 2 and minus 1. I did notice actually your textbook, I have been saying that x and y intercepts are points, which in my opinion they are, but your textbook does not follow that. Your textbook says that x and y intercepts are just x equals y equals, so you'll see that on your exam. But I just wanted to give you a heads up in case you get confused when you get to a question. Okay, B. We have y equals 2x, or sorry, x squared minus x minus 6. So we have to find something that adds to -1 and multiplies to -6. Well, with 6, we have the, to multiply to 6, we have the options of 1 and 6 and 2 and 3. If we are creative and we make our play around with the negative signs on 2 and 3, we could find something that adds to -1 and multiplies to -6. So let me set up first my binomials with my x's in there. And then we know we're going to use the numbers 2 and 3. So then we just have to make it so that they add to -1 and multiply to -6. Since what we're multiplying to, since 6 is a negative number, sorry. All right, since 6 is a negative number and we're multiplying to it, we know that one of these has to be positive and the other has to be negative. We have to have opposite signs. And since we're adding to -1, we want to make sure that the bigger number is negative. So we're going to have -3 plus 2. And if you're ever confused on these, you could go ahead and check these by just foiling this out. So you could check by multiplying, you know, x times x is x squared. X times -3 is -3x. X times 2 is 2x. So -3x plus 2x is -1x. Perfect. We got that middle term. And then we have 2 times 3, which is -6. All right, so now why don't you guys go ahead and find the x and y, sorry, just the x-intercepts and let me know what you get.
Three and -2.
Good. So your x-intercept are 3 and -2. We could also be finding our y-intercept, so why don't we do that just for practice? So to find the y-intercept, you're gonna plug 0 in for x. So on part A, we'd have 0 squared plus 3 times 0 plus 2. So our answer is 2. And then for part B, we have 0 squared minus 0 minus 6. So our answer is -6 for our y-intercept. All right, let's move on to C. Any questions so far? Okay. Moving on to C. We're looking at f of w. All right, again, this one's actually a little different. So I'm going to write it out again, but in a different way. So I can notice that I have w squared plus 2 times 7w plus 7 squared. Right? When this third value, when the y-intercept is a perfect square, and that middle term is 2 times the number being squared, then and it's 2 times that number being squared, then we can automatically factor it to w plus 7 squared. We could just jump to that. We don't really have to think much about it once we notice that. We just have to remember that. Any questions on that? Okay. So then for part C, what's our x-intercept?
-7.
Good, -7. And then what's the y-intercept?
49.
49, good. Just so you guys know, a little side note, if you have something like, I don't know, 4 equals w plus 7 squared, how would you go about solving this?
Foil it out.
Okay, that's totally reasonable and totally possible. The easier way to solve this is to just take the square root of both sides, because then the square root of 4 is 2, well, plus or minus 2, and w plus 7. Well, sorry, I don't think you need that. And then you could keep solving from there. So whenever you have something being big value being squared and it's set equal to something, take the square root to make solving easier. Okay. That's my side note. D. This one's also f of t, written in a different form than the first few. But does anyone notice anything about the numbers 64 and 36?
They're both perfect squares.
Good. So since they're both perfect squares, and we have subtraction happening, there's subtraction here, we can automatically factor this to 8t plus 36, plus 6 times 8t minus 6. And these are called conjugates. And when you FOIL this out, you'll realize that that middle term, the middle term that would be b times t in this case, cancels out and it equals 0. So you end up with your perfect squares. All right, why don't you guys go ahead and find the x and y intercepts for me.
So that's just the final answer.
Yep, that's how you FOIL it, but we have to find the x and y intercepts.
Okay.
Or that's how you factor it, I should say.
It would be negative 6/8.
Mm-hmm.
6/8.
That's one of them. What's the other one?
Positive 6/8.
Mm-hmm.
And then negative 36 for the y-intercept.
Good, perfect. Any questions on any of this so far, guys?
Should we simplify the fraction in our answer?
Yeah, you can. It's not, I don't think it's a huge deal if you do or don't. So I just want to see that you guys get the answer. All right, next is E. We have, so now we're getting into, so, you know, these first two were the same. The next two kind of involved perfect squares. And we kind of saw we could get two outcomes out of that. We can have a repeating binomial, or we could have the conjugates. And we kind of saw how that happened. This next one's a little funky because we have a coefficient in front of a that is not 1. So we have another number here we have to account for. So when we go to do these, we multiply. So if we have f of x equals ax squared plus bx plus c, we need to find something that adds to b still, but multiplies to a times c. Okay, so in this case, for part E, we need to have something that, we want something that adds to 10 and multiplies to 2 times 8, which is equal to 16. Can anyone think of anything? Any two numbers?
2 and 8.
2 and 8, perfect. So 2 and 8 are special numbers. So I'm going to go ahead and rewrite h of x. And instead of writing plus 10, right, because 10x is equal to 8x plus 2x, I'm going to write it with 8x plus 2x in for 10x. So we have h of x equals 2x squared, and I'm going to switch colors around just for a minute. So plus 8x plus 2x, and then plus 8 stays the same. Anyone confused on that? Okay. The reason I wrote it in separate colors and I separated it is because now we're going to look at both, oops. We're going to look at my magenta binomial and my green binomial, my teal binomial. Okay. Now, my goal here is I want to pull something out of these binomials so that what's left inside the parentheses is the same. Okay, so if I look first at my teal binomial, well, actually, if I leave my teal binomial alone, is there a way that I can make the magenta binomial look like the teal binomial?
Factor out x.
Factor out x, good. Oh, I'm supposed to be using t. Oh, no, I'm not. Okay, never mind. So yeah, factor out x. So this is the same as, this is equal to, I'm going to factor out x here. So then in the magenta one, I'm left with 2x plus 8 plus the green one, which is 2x plus 8. So those match. It's important to remember that in front of anything, you always have a 1. And that's important because now that we have this written in this kind of weird way, we know exactly what our answer is to factor it. We could automatically factor this to x plus 1 times 2x plus 8. As soon as those binomials are equal, you could go ahead and you take what's in purple, the coefficients of the binomials of what you factored out, and that makes one binomial, and then the other binomial is, the matching ones. Any questions on that?
Yes.
Okay.
Would it be possible, it might be more work, but would it be possible to factor out 2x out of the first one and then just 2 out of the second binomial?
Yeah,
And
so
then I think it would change the purple value, correct?
yeah, but it would also change the blue one.
Yeah.
So it'd be perfectly fine.
Okay.
Did that confuse anyone? Does anyone need me to walk through that, or are you guys good?
I have another question. When I did the problem from the beginning, I just factored out 2, like from the very first step, and I didn't split them into 2 equations. Will I get the same answer?
Yeah, you should. So if you just factor the 2 out, you end up with x squared plus 5 plus 4, and then you find something that adds to 5 and multiplies to 4. That works perfectly fine in this case. You'll see in the next case that won't work. So
Okay.
you could always try that first.
Okay.
If it doesn't work, you still want to know how to do it this way.
All right.
Okay. Any other questions? Great. Go ahead and find the x and y intercepts and let me know what you get.
-4 and -1.
And then what's the y-intercept?
8.
All right. On to F. So for F, again, we have a coefficient in front of A, and we can't just pull it out in this case. So we have to go ahead and do the method that we just did for E. So we need something that, let's see, it needs to add to -1 and multiply to -6. What numbers are we going to use?
-3 and 2.
Good, -3 and 2. So let me go ahead and rewrite my problem. So we have y equals 2w squared minus 3w plus 2w minus 3. Then I'll go ahead and I'll set up my two sets of parentheses, my magenta set and my teal set. I noticed that in my teal set of parentheses, I can't pull anything out. So I have to make my magenta set of parentheses look like my teal set. So what can I pull out of my magenta set to make it look like the teal one?
W.
W, perfect. So we'll pull a W out. And then we're left with 2w minus 3 plus 2w minus 3. So who can tell me what my final answer is?
W plus 1 and then 2w minus 3.
Good. That's the final answer to factor it. What are my x and y intercepts?
-1 and -3/2, or +3/2.
Good. -1 and 3/2. And what's my y-intercept?
-3.
Perfect. All right. Any questions on that? Okay. Next, we'll move on to problem G, which is f of x equals -x squared minus 6x minus 16.
It's plus 16.
Oh, plus 16. Minus x squared minus 6x plus 16. Thank you. All right. From here, it looks almost like we could do what we did with the first two, but we can't. But we'll go ahead and do it Abby's way, and we'll just factor a -1 out of everything. So this is the same as -1 times x squared plus 6x minus 16. Does everyone understand why we can't do it the way or factor the same way that we did for the first two problems?
No.
Is a negative.
Good, because there's a -1 here. So there's a coefficient that's not just 1. So we have to get rid of that negative. So to get rid of it, we just factor a -1 out. All right, now we could just tag along that -1 and yeah, and we could go ahead and factor this. So we'll set up our two sets of binomials with x's. So what adds to 6 and multiplies to -16?
2 and 8.
2 and 8, good. And what's going to be positive and what will be negative?
Eight will be negative, and 2 will be positive.
Careful, because we're going to have, if 8 is negative and we add 2 to it, then we're adding to -6. We have to add to +6. So 2 will be negative and 8 will be positive. Does that make sense?
Yeah.
Very cool. All right. So now that we've factored this, go ahead and find the x and y intercepts. +2 and -8, good. So -8, +2. And what's the y-intercept?
16.
16, perfect. All right, next is problem H, which is px equals 2x squared minus 6x. Okay, now we're on to a fourth way that we can factor. These I always liked these the best, so I hope maybe you'll feel the same way. We are going to just take out the greatest common factor. And here the greatest common factor is 2x. So 2x, which leaves us with x squared, x minus 3. And now go ahead and find the x-intercept and the y-intercept.
X-intercept is 0, 3.
Good, and what's the y-intercept?
0.
Perfect. Any questions on that one?
Where does the 0 and the x-intercept come from?
So when you set 2x times x minus 3 equal to 0, just like we did with when we multiplied two binomials, you set 2x equal to 0 and then x minus 3 equal to 0. So then when you divide this by 2 on both sides, you get x equals 0 and then add 3 here,
okay.
x equals 3.
Alrighty, thank you.
You're welcome. All right, next, any other questions? All right, problem I. M of t equals minus 5t squared plus 2t. Okay. This is, you guys aren't gonna like this one, but we're gonna do the same thing that we did in H. We're just gonna pull out the A coefficient. We're gonna factor that out along with a t. So this is the same as minus 5t times, that leaves me with t here, and then in that second term here, it leaves me with negative 2 divided by 5. And then since I'm adding a negative, I could just go ahead and just write this as minus. Anyone confused on that?
So you just divide 5 and then just put the 5 like under the 2.
Yep, so what I'm doing is whenever we're factoring anything out, what we're really doing is we're dividing by what we're factoring. So what happens here is we're actually doing divide by -5 and divide by -5. It just
Okay, I
happens
got it.
that here we end up with 1t squared.
Okay.
But
Thank
here
you.
we're left with the 2 divided by -5.
Okay.
Good question. Thanks for asking that. All right, so now go ahead and find the x and y intercepts for me.
Zero and 2/5.
Good. And what's that y-intercept?
0.
0. Good. All right, any questions on this first page about anything? Okay. Moving, I don't know why up
Excuse
here.
me.
Yes.
Can you just go over the when we have to add to b and then multiply the 2 to a times c? I think that's letter G maybe,
Okay.
or it's letter maybe E. When we went over, I didn't really get it.
Oh, okay. I see what you're saying. Yep. So if you look up here first, when we have something in the form with where the coefficient here is not 1, so up here that a is equal to 1, but down here it's anything but 1. It's just not 1. We're going to find something that adds to the b value but multiplies to a and c. So, I mean, it sounds kind of like, well, obviously a and c multiplies to a times c, right? But it also has to be able to, those two numbers also have to add to b. So, oops. Let's do, yeah, we'll do question E. So the way question E is written, we have h of t is equal to 2x squared plus 10x plus 8. So I want something that adds to 10x, but multiplies to 16. And the 16 comes from 2 times 8, which is a times c. Are you with me?
Yeah. Okay. So then, is that why the next parentheses is 2 and 8?
Yeah. So I went and well, it just happened to be that way that that's why it was 2 and 8. It was 2 and it's 2 and 8 because 2 and 8 is the numbers that also adds to 10. So if you were to look at problem F, so we're adding to -1, but we're multiplying to 2 and -3. This is another bad example. Why they really sucked at picking these, I think. But then what adds to -1 is -3 and 2, and -3 times 2 also multiplies to 6. So that's why I put it here. But
So then, where would you plug it in? Like, it says equals w, then 2w minus 3 plus 2w minus 3. So where would I plug in -3 and 2?
so we already did. We plug it in right here. Instead of writing it as -1, because right, I do agree that -1 is equal to -3 plus 2. Do you agree with that statement?
Oh yeah, okay, I get it.
Yeah. So now I'm just I'm writing it in a more complicated way, but I have to do that in order to get my sets of parentheses.
Okay. All right, thank you.
You're welcome. All right, and I'll scroll back down to I for a minute. There you go. I'll give you guys a second to catch up. Any other questions? Okay. Am I good to go to the next page?
Yes.
All right. Okay. Problem 2. A model rocket is launched vertically from the ground with an initial velocity of 168 feet per second. Let h of t be the height in feet of the rocket t seconds after launch. In order to do this problem, you had to have looked in the textbook, and actually, I'm sure it's in the lecture videos as well. But the textbook has a nice little equation, because this is definitely a more physics-based problem, or physics-inspired problem. It has a nice question or equation. It's on page 72 of the text. And it's the height of a projectile above ground with respect to time, and it's given by -16 t squared plus the initial velocity, which we call v sub 0 of t, plus the initial height, which is a sub 0. So first, a projectile is something like a rocket launch. So if you have your ground here, you have some rocket being launched. Right, kind of like the Mars rover yesterday. And then its projectile path is gonna do something like this. Okay, and then it's gonna hit the ground, right? It's gonna go up and it's gonna make this parabola. In our scenario, we know that when it's first launched, the initial velocity, so when it first launches, the initial velocity is 168 feet per second. And we also know what the initial height is. Right, this initial height here, when it's launched, is h sub 0 equals 0 feet. We're launching it from the ground. Okay, so that's what our projectile, that's what's happening here. We want to, for part A, we want to write a formula for the function h of t. So h of t is equal to, we're just gonna plug what we need to plug into here. So -16 t squared plus our initial velocity, which is 168.
Is the -16 just like a constant?
Yeah, it's a constant, and in these scenarios, it's always there. It comes from physics.
Okay.
So 168 times t plus the initial height, which is 0. So you don't even need to add that 0 in. You could just have -16 t squared plus 168 t. Any questions? Okay, part B. Find t when the model rocket hits the ground. So to find when this hits the ground, how are we going to set up the equation?
set h of t equal to 0.
Good, so h of t equals negative 16t squared plus 168t, set it equal to 0. So why don't you guys go ahead and factor this one, and let me know what you get when you factor it. So what's the next step? Just for the sake of time, I'll go through it quickly. We're just going to take negative 16t out of this equation. So we pull out a negative 16t times, and then we're left with t plus, if you do 168 divided by negative 16, you actually get, it should be t minus 10.5. Then from here, set both these equal to 0, negative 16t equal to 0, and t minus 10.5 equal to 0. So here t is equal to 0, and t is equal to 10.5. So the rocket hits the ground. At 10.5 seconds. Ooh. All right. Part C, we have to find the maximum. And when we're finding the maximum, we want to find the vertex. So to find the t component of the vertex, so t vertex, remember we do, we add our two, we find the midpoint. So we do, we add both of our x-intercepts together. So 0 plus 10.5 divided by 2, which is equal to 5.25 seconds. But we're looking for the maximum height. So now we have to plug that, this 5.25 into the equation of h. So negative 16 times 5.25 squared plus 168t. And I'll let you guys go ahead and solve that out, but you should end up getting 441 feet. So the max height is 441 feet. Any questions on anything?
Would you also